Have you ever felt like you're stuck in a loop, just rewriting the same lines of code over and over again? Well, today, we're going to pull back the curtain on the secrets to building smart, reusable Java code that actually saves you time and a whole lot of effort. We're going to explore the fundamental building blocks that let you create really complex applications without having to start from scratch every single time. So, how do you get out of that endless cycle of rewriting code? Well, the answer comes down to a set of really powerful, reusable building blocks that are right at the heart of efficient Java programming. Okay, let's dive into this and see exactly how they work. All right, our first building block is all about how we bring objects to life. It's a special kind of method that basically lays the foundation for every single object you create in your program. So, this special method? It's called a constructor. You can think of it as the assembly instructions for a new object. The very moment you create an object, the constructor just kicks in automatically, setting up its initial state and making sure it has everything it needs to get up and running. I bet you've written a line of code that looks just like this 1,000 times. It seems super simple, right? But there are actually two totally distinct and crucial things happening here. First up, that new keyword tells the system, hey, go carve out a piece of memory for our new car object. Then, immediately after that, the caro method, that's our constructor, is automatically called to get that new object ready for action. It's like a two-step dance that happens in a flash, every single time. Now, constructors have some very strict rules you gotta follow. As you can see, they have to have the exact same name as the class. They also have no return type, not even void. And you never, ever call them directly. They're always invoked automatically. These rules might seem a bit rigid, but they're absolutely essential for making sure constructors do one thing and one thing only: initialize objects. Okay, so imagine you're making a person object, and you need to set their name. You might have a parameter in your constructor called name, but the person object also has its own name attribute. So how do you tell them apart? That's where the this keyword comes in. In the code you see here, this.nome refers to the object's own attribute, while the nome on the right is the parameter that's being passed in. It's a really simple trick to avoid any confusion and keep your code nice and clean. All right, on to our next building block. We're going to look at a technique that makes our methods way smarter and more versatile, basically allowing one method name to do a bunch of different things. This technique is called method overloading. It's this cool ability to define several methods that all share the exact same name, as long as their parameter lists, what we call their signatures, are different. They can be different by the number of parameters you give them or by the type of parameters. And this is a perfect example. We've got two methods here, both called multiplica. One is built to work with integers, and the other is for doubles. Based on the kind of numbers you feed it, the Java compiler is smart enough to automatically figure out which version to run. It's fantastic. No guesswork required on your part. So why bother doing this? Well, it lets us use really simple, intuitive names like print or multiply for all sorts of different data types, which just makes our code so much easier to read. And here's the fun part. You've already been using it, probably without even realizing it. System.out.println is a classic example of an overloaded method that can print strings, integers, you name it. Okay, now for the real heavy hitter, the most powerful concept for building scalable applications: inheritance. This is where we stop copying and pasting code and start building really intelligent, reusable class hierarchies. Inheritance is pretty much exactly what it sounds like. We create a brand new class, which we call a subclass, and it automatically inherits all the attributes and methods from an existing class, the superclass. This is the absolute foundation of the is-a relationship in programming. And how do we actually establish this relationship in Java? It's all thanks to one simple keyword: extends. As you can see right here, vehicle1 extends vehicle. That means vehicle1 is a more specialized version of a vehicle. This single line of code instantly gives our new class all the powers of its parent. The workflow for this is incredibly logical. You start with a general idea, your superclass. Then you use extends to create a more specific version, the subclass. Right away, that subclass gets all the functionality from its parent, and then you're totally free to add new, specialized methods and attributes to it. So what does this actually mean in practice? It means an object of our new vehicle1 class is now a hybrid. It's got all the methods it inherited from the vehicle class, like acelera and freya, plus its own unique methods, like Liga and Desliga. We've just successfully reused a bunch of code and extended its functionality all at the same time. Okay, so we've seen all the individual pieces. Now, let's put it all together and see how these concepts work in perfect harmony to model a real-world system. We're going to model a university. So at the very top, we'll have a general membro universidade class, a university member. From that, we'll derive a more specific alumno class for a student. And from that alumno class, we can get even more specialized with a bolsista, or scholarship student class. See, the whole foundation is built with inheritance. A student, or alumno, is a type of university member, right? So we use the extends keyword to lock in that relationship, instantly inheriting basic things like a name and an ID. But wait, how does a student object get those attributes from the university member class? Well, that's where the super keyword comes into play. You can think of it like a chain of command. When you create a student object, its constructor immediately calls super to run the constructor of its parent class first. This makes sure the entire object is built correctly, from the top down. And there you have it. This shows the true power of combining these ideas. We end up with a clean, logical, and really efficient hierarchy. Each class is only responsible for the stuff that makes it unique, because it inherits all the common functionality from its parent. This is exactly how you build complex systems that are easy to maintain and expand later on. So we've seen how constructors create our objects, how overloading makes methods flexible, and how inheritance lets us reuse a massive amount of code. The question I want to leave you with is this. What other real-world systems, from a product inventory in a store to a biological classification of animals, could you model using these same powerful building blocks?